So in this section, we're going to be talking about mid-segments of triangles. And as I said before, triangles are a huge part of geometry. And there's lots of different things within triangles that can help us find missing links or missing angles or other things about those triangles. So triangles are a huge part of geometry. So that's what we're going to be looking at for the next foreseeable future. Okay? All right. So first of all, we need to know what is a mid-segment. Definition. It's a segment connecting the midpoints of two sides of a triangle. So if I'm looking at my picture here, segment MN is a midsegment of triangle ABC. So if it's a mid-segment, what do I know by definition here about points M and N? What about the points, though? What does it say in the definition that a mid-segment does? Good, it connects two midpoints. So I know that M and N would have to be midpoints of their respective sides of the triangle. So if M is a midpoint, then what do I know about AM and MB? What do you know about the pieces, the segments from A to M and the segment from M to B, if M is the midpoint? Good, they're congruent. So I would know that I have congruent pieces if I know that I have a mid-segment. So I would know that AM is congruent to MB. Okay. What about on the other side? If I know N is a midpoint, what do I know there? Good. AN and NC are also congruent, so we can mark those as well. Okay. So if we know we have a mid-segment, by definition, we know we've got midpoints, and if we have midpoints, we have congruencies. Okay. Vice versa is also true. If I know that I have midpoints that are being connected, then I know that I have a mid-segment. So by knowing that I have a mid-segment, I also know some other things about my triangle here. Okay? The triangle mid-segment theorem tells me if a segment joins the midpoints of two sides of a triangle, then that segment is parallel to the third side and half its length. So let's think about what it's telling me here. First and foremost, it's telling me if I've got a segment that's joining the midpoints of two sides, or aka a mid-segment. So we're talking about M to N, it's a mid-segment. So we've got those congruencies to show that. Okay? Then it's telling me that segment, MN, is parallel to the third side. So which side would MN have to be parallel to? Yeah, BC. So we know that MN would have to be parallel to BC, okay, by this theorem. Now, how can I show that they're parallel in my picture? What's used to show that I've got parallel segments? Good, my arrows. So I could show in my picture that these are parallel by showing those arrows. Or, if you know that they're parallel and you know they're the midpoints, then you're going to know it's a mid-segment. Now, let's look at the second part. It says that that segment is also half the length of the third side. So that tells me that if I'm looking at the length of MN, that it is half the length of it, the side that it is parallel to, which would be BC. So since we know that the mid-segment's half the length of the third side, if I knew what that mid-segment measurement was, I could double it to get the third side. So if I'm looking at my picture here, BC would be equal to double your mid-segment MN. All right, so in our first example, it says in triangle XYZ, so that's my larger triangle, N and P and M are midpoints. Okay? Then it's telling me the perimeter of MNP, that's the small triangle, is 60. It wants me to figure out NP and YZ. Okay. All right, so let's start with what we know. If M, N, and P are midpoints, then what do we know? Well, if I know I've got midpoints, then what else do I know I have? Yeah, I've got some congruent pieces. So if P is the midpoint, I know X to P and P to Z are congruent. If N is a midpoint, then Y to N and N to Z are congruent. And if M is a midpoint, then X to M and M to Y are congruent. Okay? What else, though? Think about the segment MP. It's joining two midpoints. So what's it called?
Mid-segment.
It's a midsegment. Would it be true for MN and NP as well? Yeah, so we can use the fact we know we've got midsegments because they're connecting midpoints of two sides of a triangle. So we can use that to help us be able to figure out some of our measurements here. Okay? So the first one it's asking me to find is N to P. So what other piece of information might be helpful for me to figure out what N to P is? Okay, my 22 and 24, absolutely. What else can I use? My 60. Okay, it told me that my perimeter all the way around is 60. That's all three sides added together. Well, we know two of the sides, so what can I do?
Add them together.
And good. Add them together, subtract it from 60, or you can subtract each one from 60. So NP is going to be equal to 60 minus 22 minus 24. So what is NP going to be? 14. Second part is asking me to find from Y to Z. So any ideas there? Brandy? Good. We know that MP is a midsegment, and it would have to be parallel to this bottom piece, YZ. And not only is it parallel, but it's half its length, correct? So if I know that 22 is half, double it, and what is Y to Z then? 44. So I know that YZ is double MP, which is 22, 44. Now, it didn't ask for the other sides of the triangle, but could I find them pretty easily? Yeah. What about XY? This side of the triangle. 28. How'd you get it? Good. NP or PN is parallel to XY, so therefore it's half its length. It's a midsegment, so we know that this one would be 28. What about X to Z? What would it be? Well, X to Z is parallel to which one? Yeah, MN. So MN is 24, which would be half. Double it, gives me 48. All right, this one is asking me to find the measure of angle AMN and the measure of angle ANM. Okay? Now, so look at your picture. What's something I know from looking at my picture? Go ahead.
The angle CBA is 75.
Good. CBA or just B, that would be okay to call it B, okay, is 75 degrees. So it told me that. All right, what else do I know? Good. It looks like I've got some isosceles triangles, okay, because I've got some congruent sides. What else do I know that's going to give me? Yeah, if I've got some congruent sides, then I'm going to have some congruent angles, okay? What else? What do those tick marks tell me about segment NM? That N and M are midpoints, so therefore it is the mid segment, okay? So that's going to help me. So if it's the mid segment, what can that tell me to help me with that? So my mid-segment theorem told me that these two sides, or these two segments rather, are parallel. So I know that NM and CB have to be parallel to each other because NM is the midsegment there. Okay? So it's looking for AMN, and that's this angle here. So what could I use? Here's that line that's cutting down through them. What could I use to help me figure out what angle AMN is? Not 180 minus 75. Think about your relationships. What relationship would that angle AMN and 75 have?
Corresponding.
They're corresponding, so they would be the same, okay? So, measure of angle AMN is 75 degrees. And it is because of those corresponding angles. Okay? Now, what about angle ANM? So that's on the other side. That would be this angle. Any ideas there? Okay, how do you know it's 75?
Because you're the 175.
Okay, but how do we know that they would both have to be 75? Good. It's an isosceles triangle. We pointed that out a minute ago and said, well, if that triangle ANM has two congruent sides, it also has two congruent angles. So my other angle, ANM, would also have to be 75 because it is an isosceles triangle. So it is 75 degrees since triangle ANM is isosceles. Good. All right, so EB should be half of DC, which was 18, which is going to make it how long? Good. So EB is 9. Now, how did you know that it was going to be half? How did you know it was a midsegment? Good. Because of my tick marks told me that E was a midpoint, B was a midpoint. So you have to know those things. You have to have those things present before you know it's a midsegment and before you can automatically assume it's half. But it is, so we're good. Okay, so EB is 9. All right. All right, so BC, we've got tick marks there. It's congruent to AB. So therefore, BC is 10. There we go. All right, so the last one, AC, it's come together, that AB and BC. We know that BC is 10 because they're congruent. So therefore, the whole thing would be 20. Thoughts on this one? It's kind of like an informal proof. Yes, it is, because it's asking you to justify, so you're having to give reasons. Yes, ma'am. Okay, so she said 65 degrees by corresponding angles, okay? But how did I know I had corresponding angles? Okay, how did you know they were parallel? Good. The tick marks told me that I had a, what? Mid-segment, and we knew by mid-segment theorem that meant that I had two parallel lines, okay? So I knew that UV was parallel to XY since UV was a mid-segment. Okay? And so we knew it was a mid-segment that told me they were parallel. So then I could zoom in and look just at those parallel lines. This transversal, it's asking about this angle, VUZ, and those are going to be corresponding. So therefore, measure of angle VUZ is 65 degrees, and that's by corresponding angles. So this is kind of like a mini proof. It doesn't say that it's a proof, but when it says justify, you're kind of writing that informal proof, okay? And if you just had the corresponding angles part, that's important, but you also need to make sure that you explained, well, how did it, because if you've got corresponding angles, that means you have to show that you had parallel lines, and it didn't mark any lines parallel, and you knew they were parallel because of those congruent markings you had mid-segments, okay?